Hello and welcome to the GCSE Chemistry tutorial for topic C6, the rate and extent of chemical change. This is part 2 and covering reversible reactions. Reversible reactions are shown with this symbol here. Reversible reactions can reach an equilibrium. What does this mean? Well, as a reaction occurs, the concentration of reactants decreases and the forward reaction slows down. At the same time, the concentration of the products increases and the backward reaction speeds up. When the forward and backward reaction is at the same rate, the reaction reaches equilibrium. This can only occur in closed systems, so a system where, for example, gases can't escape. An example is the thermal decomposition of hydrated copper sulfate. If you heat hydrated blue copper sulfate crystals, it turns into white anhydrous copper sulfate powder. That's an endothermic reaction. If you then add water to the white anhydrous copper sulfate powder, it turns back into blue copper sulfate crystals. What is Le Chatelier's principle? Well, it's a principle that states that if the decretions of a reversible reaction at equilibrium are changed, the reaction will counteract that change. So, for example, temperature. A decrease in temperature, the equilibrium will move in the exothermic direction. An increase in temperature, the equilibrium will move in the endothermic direction. In terms of pressure, for gases only, an increase in pressure, the equilibrium will move in the direction of less molecules. A decrease in pressure, the equilibrium will move in the direction of more molecules. And finally, concentration. An increase in the concentration of reactants, the equilibrium will move to make more products. A decrease in the concentration of products, the equilibrium will move to reduce the amount of reactants. An example of this is the Haber process, which makes ammonia. This is a reversible reaction, and the reaction is exothermic. A decrease in temperature will move the equilibrium to the right, so you'll make more product. An increase in pressure causes the equilibrium to move to the right, as there's less molecules of gas on the right-hand side. If the concentration of the reactant is increased, more product is produced. If you pause the tutorial and try and answer these questions now. The symbol for a reversible reaction is shown here. Using Le Chatelier's principle, explain what factors can affect the equilibrium in the Haber process. Going back to this example here, where you would decrease the temperature and increase the pressure, increase the concentration. We'll look more at the Haber process when we look at fertilisers. In summary, we've looked at reversible reactions.